All right, so this week we're going to take a look at section 6.3. Okay, that's going to be on graphing sine and cosine. Sine and cosine are the kind of the easiest two ones to graph. We are going to look at the tangent, cotangent, secant, and cosecant, but we'll save that for next week. Okay, so first of all, when you graph sine and cosine, they're different than any of the other graphs we've studied this year. Okay, we've studied all kinds of graphs. We've done radicals, rationals, we've done polynomials, logarithmic, exponential. I think those are the major ones we've done. But sine and cosine are what we call periodic functions. Does anybody know what the graph of sine or cosine looks like? Yeah? Yeah, it looks like a wave. And the idea of periodic, it means that the graph repeats. Right? So basically you just keep seeing that same wave pattern over and over. Okay, that's sine. Now if I do cosine, it looks very similar. What if we talk about it in terms of like a transformation? What kind of transformation could you do to change the blue one into the red one?
Horizontal shift.
A horizontal shift. Yep. By how much? We'll talk about that. But yes, if you did a horizontal shift, you could turn the blue one into the red one. Yep. Let's take a look at that. Let me graph just this part. And I want to focus on what we call one section, okay, of this wave, okay, or one cycle. So one cycle is basically how far you have to trace along the graph before it starts repeating. For this graph, one cycle is right there. That's considered one cycle of the graph. So the amount of distance you have to trace is from here to there. We'll talk about how long that is in a minute. Yeah, it's 4 tick marks, but each tick mark is not one unit. So we'll talk about what it is. So what's going to happen is if you trace beyond that, you're just going to see a repeat of what you already did. So if I describe this in terms of like the y values that you hit, you start at 0. The highest you hit is 1. Then you go back to 0, -1, 0. And those numbers are going to keep repeating. 0, 1, 0, -1, 0. 1, 0, -1, 0. 1, 0, -1, 0. You just keep getting those same y values over and over and over. You get other y values too. I'm just naming the highest, the middle, and the lowest. Those are the ones I kept naming. So the idea is those y values keep repeating. Right? 0, 1, 0, -1, 0. 1, 0, -1, 0. They keep repeating in exactly the same sequence over that distance that I traveled. Okay? If you don't travel far enough on the graph, they won't repeat. Okay? You've got to travel exactly that far. That's how far you travel before you start seeing repeats. I want to talk about how far that is. Based on what we've studied about sine and cosine so far, does anyone have a guess how far you have to travel along the x-axis before that graph is going to repeat itself? Yeah?
Sine of 4.
No, not the sine of 4. Think about it in terms of like a unit circle. How far around do you go before the coordinates on the circle start repeating? And once you get to this point, you're going to end up with basically back where you started. Yeah?
2 pi.
2 pi. Yep, and that's 2 pi
Radians.
Radians, yes. So the x-axis is an angle. So let's say, 2 pi. That's where it ends, the first cycle. So it ends at 2 pi, and it starts at 0. So from 0 to 2 pi is the first cycle of of the sine graph. So what do you think the halfway point in the cycle is? Pi, yeah. So that's pi. So that's pi is halfway, and pi over 2 is a quarter of the way. Does anybody remember what pi over 2 is in degrees? 90, yep. So each tick mark on this graph is 90 degrees. 0, 90, 180, 270, and 360. So the length of that interval before the graph starts to repeat itself, okay, that is called the period of the graph. You might also hear me say like the cycle of the graph, it's the same thing. But the period of the sine and the cosine graph is 2 pi, or 360 degrees. So if I wanted to see exactly one cycle on my screen, okay, not more than one, just one, I could set my x min to 0 and set my x max to 2 pi. Let's try it. Let's go 0 to 2 pi, hit graph, and now I'm looking at exactly one cycle. What if I wanted to see 2 cycles? Instead of 0 to 2 pi, what could I do?
0 to 4 pi?
Yeah, I could do 0 to 4 pi. Notice you can type in 4 pi. It's going to change it to the decimal as soon as you press the down arrow. So 0 to 4 pi, that's going to show me exactly 2 cycles. There's 1, 1.5, and there's 2. So any question on the length that you have to set your window to see one full cycle? All right, now, notice when I did that one, I was in radians. If I switch to degrees, and I don't change anything in my window, things are not going to look right. It doesn't look like a sine or cosine wave at all. That's because you changed the mode, but you didn't change the window. If I want to see one full cycle in degrees, it's not 0 to 12.5 degrees. What would one full cycle be in degrees? Yeah? 360. I need to make this a 360. So I can get exactly the same picture in degrees or radians. It's just a matter of what mode I'm in. So if you notice your sine or cosine graph is kind of like a straight line, and it's not looking like a wave, it's probably because you changed the mode and you didn't fix the window. We're going to do mostly degrees. Mostly radians, sorry. Radians. Okay, and a period is also called a cycle. I mentioned that already. So I said that sine and cosine are periodic functions. Actually, every trig function is periodic. We are not going to look at this one this week, but if you graph tangent, it looks different, but there's still a pattern to it. There's a pattern that repeats over and over. And that's the key about every trig function. Once you know what one section looks like, you can kind of just copy and paste it, and that's what it looks like forever. A little more complicated with tangent. We get into some vertical asymptotes and some other things. So we'll talk about that next week. So any questions on that so far? Okay. So how do we graph sine and cosine? Well, we really need 5 points. When I talk about finding 5 points, I generally find the start, the stop, the high, the low, and what's right in the middle. You can do more points, but 5 is generally enough to do one cycle. And when you're doing a sketch, that's all you have to do, one cycle. Because my thought is if you can sketch one cycle, all you have to do is copy and paste it to do a second cycle. Right? So we know the graph goes on forever, but we're just going to sketch one wave. Okay. All right, this is basically the same thing I just showed you. You got your 5 points. And all of the points, I think we already said that, they're all 90 degrees apart. So 0, 90, 180 is halfway, 270, and 360. Now, we can change the points being 90 degrees apart. If you do a horizontal stretch or compression, that's the only graph, that's the only transformation that can mess up that spacing of 90. Shifting left and right doesn't, shifting up and down doesn't, stretching doesn't, up and down. But stretching left and right work. So if I do something like this, when you put a number inside the parentheses, that's a horizontal stretch or compression. And remember, it's the opposite. So the bigger you make the number, the more compressed it gets. So now you can hopefully tell, looking at it, that's not a normal sine function. That's been compressed. Which means these points have all been squished together too. So they're not 90 degrees apart anymore. We'll talk about what they are apart. That'll be on, that'll be tomorrow. Okay, so anytime that we do a transformation, what we're going to do, we're going to make a table. The table is going to be the coordinates of these 5 points. So all I'm going to want to know when you graph is what happened to those 5 points. Okay, did they shift up? Did they shift down? What happened to them? Well, in order to know what happens to them, you have to know where they start. Okay, once we know where they start, we can say, all right, let's shift them all up 1. So we just take the starting points, and then you like add 1 to the y values. That would shift them up 1. But if you don't know where they start, we can't figure out where they end up. All right, so here's our table for sine. And that graph is accurate. That's an exact picture of what sine looks like. So let's start with this coordinate. What's the coordinates of that first red dot?
0, 0.
0, 0. Yep. So that's the first point in your table. So sine starts at 0, 0. Okay. Second coordinate. That marks the quarter point in the cycle. What's the coordinates of this red dot?
0, 1.
Yep.
1 pi over 2. No, pi over 2, 1.
Yeah. Pi over 2, 1. So that's your second one. So pi over 2, 1. How about the third? The third coordinate, which marks the halfway point in the cycle. Pi 0. Okay, that's the third coordinate. Pi 0. Okay, fourth one. Right there. What's the coordinates of that fourth point, which marks 3/4 of the way through the cycle? 3 pi over 2 negative 1. Yep. And then the last point is the same as the first point. It's back at 0. So this last point is 2 pi 0. And technically this last point right here is really the first point of the next cycle. Okay. So those are all your points for the sine table. Okay. Any question on where those come from? Okay. Now let's get the same thing for cosine. Okay. I don't have cosine drawn on the Smart Notebook, but let me just do it on the calculator real quick. I don't know if you noticed or not, I'm pressing Zoom 7. So we do Zoom 6 a lot when we do algebra functions on the calculator. We'll do zoom 7 more when we do trig. Zoom 7. Alright, let me make that so we can see it a little better. Okay, so the first cycle in the cosine function, you're looking at these points right here. Those are the 5 points that I want to put in the table. The x values are the same. Okay, we're picking x values that are all 90 degrees apart. So we're still going to pick 0, pi over 2, pi, 3 pi over 2, 2 pi. Now, what is my first y value going to be? Yeah.
1.
Yep, it's going to start at 1. And then the next y value is going to be 0. So we go to 0. Okay, my third y value is -1. Okay, next one, 0, heading back up. And the last y value, always the same as where you started, because that last point is really the beginning of the next cycle. Okay, so these are what we call the original points for sine, and then the original points for cosine. And you can put those tables on a reference sheet if you want to for a test. Okay, any question on either one of those tables? Okay. So what we're going to start out doing is looking at individual transformations. That means that each problem is only going to have one thing done to it. What's an example of one thing? Okay, shift up. That's it. Okay. Shift left. That's it. We're not going to look at any problems today that have like shift up and left in the same problem. Okay, so one transformation per problem. And if you're only doing one transformation per problem, let's say you're shifting up. What does shifting up affect? If you like took a coordinate and shifted it up, what would change about the coordinate? The y would change. So if we shift up, the y's are going to change, the x's are going to stay the same. So our first thing we got to figure out is which column is going to change and which column is going to stay the same. And that'll depend on the transformation that we're doing. Okay, so everything up to that point was pretty much just background about sine and cosine. Now I'm going to show you guys how to do the two shifts today. Shifting up and down and shifting left and right. So the first one we'll look at is the horizontal shift. When we deal with trig functions, they usually call a horizontal shift a phase shift. But it's just a horizontal shift. So horizontal shift is when your graph is translated left or right. Okay, so think about that for a second. Moving left and right. If you had a coordinate and you moved left or right, what part of the coordinate is changing? The x. Yep. So when we do horizontal shifts, or phase shifts, the x is going to change. The y is going to stay the same. Okay, when we do any kind of horizontal transformation, where do we look for the number? Is it inside when you do horizontal, or is it outside?
Inside.
It's inside. Remember, horizontal stuff is always inside. Okay, second question. Is it multiplying, or is it adding or subtracting? Which one would be the shift? Adding and subtracting. Yep. So just like every function we've studied all year, if you see a plus or a minus on the inside, that's a horizontal shift. Plus or a minus on the outside, we're going to do next. That's a vertical shift. right, so now let's break it down, whether it's a minus or a plus, in which way it goes. If you have a minus on the inside, which way does it shift it?
Right.
Minus shifts it to the right. And if something is moving to the right, what's actually happening to the x value? Think about it carefully. If something moves right, the x value is getting bigger, right? So, and it seems kind of weird, but it's always the opposite. Horizontal shifts, when you have minus, it moves to the right, okay? The x value is actually getting bigger. How about if you had plus inside? That shifts it to the left, which actually means the x values are getting, right, they're actually getting smaller. So even though you see a plus here, it's the opposite. They're getting smaller. Okay? So we're going to have to remember that when we do the shift, that it's the opposite. Let's So next we'll talk about how do we change the table, right, when we do a horizontal shift, and then I'll show you guys how to do a sketch. Okay, so everybody have these last two? All right, so how do you take the 5 points in that original table that I gave you and modify them when you do a horizontal or phase shift? Well, first of all, the easy part, the y's stay the same. So you look at the original table that I gave you, and when you're writing your answers for the final table, copy the y's down from the original. Those stay the same. Now be careful which table you copy from. For the first problem we're going to do, you're copying from the sine table, because the problem is about sine. If you're doing a problem about cosine, copy it from the cosine table. Okay, so the y's are staying the same, the x's are changing. Someone remind me in this one, what's actually happening? The graph is going to move which way? Right. It's going to move to the right, which means the x values are really going to be getting bigger. This is the transformation where you need to do the opposite of what you see. So look at your graph, look at your equation, and determine what has been added or subtracted. In this case, it says minus pi over 2. You're going to do the opposite of that. So you're going to do the opposite of that to all the original x values. So we have a minus pi over 2. That means we are going to do a plus pi over 2 to all the original x's. And adding something to all the original x's is going to shift them to the right. And that's exactly what's supposed to happen. It's supposed to move to the right. Right, so pretty much the general thing we do for every problem. We start with the original points, we modify them to get the new points, and then we make a sketch. Right, so let's see if we can graph example 1. So it's sine of x minus pi over 2. Okay. On the test, all the different transformations are going to be mixed together. Shifting up and down, left and right. The first thing you have to recognize is what that is. That's a horizontal shift because it's subtracting inside parentheses. Okay, let's make a table. When we do a horizontal shift, which column stays the same? The y's. So let's get the y's out of the way. If we go back to the original table for sine, can someone remind me what are my 5 y values? Yep.
0, 1, 0, 1, 0.
Yep. Okay, and that's it. Those are my final answers for my y values. Okay, now I need my x's. Well, off to the side, I'm going to put the originals. Not in this box. In that box is going to go the final answers. Can someone remind me, what were my 5 original x values for sine?
0.
Yep.
Pi over 2. 2 pi. 3 pi over 2. And then 2 pi.
2 pi. And remember, these are just 0, 90, 180, 270, 360. They just give us 5 nice points. Okay, determine what we've added or subtracted. Okay, we've subtracted pi over 2. You need to do the opposite of that. So what's the opposite of subtracting pi over 2? Yep, adding pi over 2. That's what we need to do to all of these. Okay, I'll start with the first one. 0 plus pi over 2. That's just pi over 2. Okay, the second one. Pi over 2 plus pi over 2. When you want to add 2 fractions, what do you have to make sure you have? We already have a common denominator for this one. So what's pi over 2 plus another pi over 2? That's a 2 pi over 2. And when I reduce that, I just get pi. Okay, how about the next one? Pi over 1 plus pi over 2. Do those have the same denominator? No. What's the common denominator between 1 and 2? 2. So I can multiply the bottom by 2, make it a 2, and multiply the top by 2. That gives me 2 pi over 2 plus 1 pi over 2. 3 pi over 2. Okay. Next one. It already has common denominator. Before you reduce it, what's 3 pi over 2 plus 1 pi over 2? 4 pi over 2. And what does that reduce to? 2 pi. And if you think of the pattern before you reduce it, you should be able to figure out the last one. This was 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Yep. So a lot of times, once I see the pattern, I just go with the pattern. But if you don't see the pattern, you can find the common denominator and go from there. Okay, so that's your new table. Any questions on the table? The table is going to be worth most of the points in this problem. On the test, the way I have it set up, I give you 1 point for every x and y value you get right. So this table is 10 points. Okay. And then the graph is usually about 2 points. That's easy once you get the table. Okay, so let's set up our graph. First thing, whenever you label a graph, you have to make sure that your labels are spaced the same. So if you want to go by 2s, you can go by 2s or 3s, but you got to just go by the same number. Were these original x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi, were they evenly spaced? Jacob?
Yes.
Yeah, they were all 90 apart if you think of it in degrees. We took a bunch of things that were equally spaced, and we moved them all together. So are they still equally spaced? Yeah. Because they're equally spaced, you can use those as your labels. And that's what I would do. So I would label this 0, pi over 2, pi, 3 pi over 2, 2 pi, we need one more, 5 pi over 2. You don't really want to number your graph 1, 2, 3, 4, 5, 6 because these aren't nice numbers. So label your axes using what's in your table, and then your points will be on nice grid lines. Okay, on the y-axis, what's the highest?
1.
And the lowest? All right, so that's fine. You just go like that. Okay, and now graph all your points. So the first one is pi over 2, 0. The next one is pi 1. 3 pi over 2, 0. 2 pi, you go down 1, and 5 pi over 2, back at 0. Okay, so this is the new one. Remember, when you sketch it, just try to make it look curved. There's nothing about these graphs that are like sharp turns. Okay, they're all curved. Now, you don't have to do the original, just to show you where the original would have been. Would have been these red dots right there. So that's the original. So you can see the new one shifted pi over 2 units to the right, or 90 degrees. Any question on that? And we know the pattern repeats, but we're only sketching one section. And what's that called? One section? One cycle. Okay, one cycle, one section. Yeah. Okay. Questions on that? All right. So that was a sine function shifted to the right. Let's try a cosine shifted the other way. Again, it's a phase shift. And we know that because it's adding or subtracting inside the parentheses. Okay, let's do it again. What stays the same when you do a phase shift? Yep, the y's are going to stay the same. So now I need my y's for cosine. And that's different for sine. So what are my y's for cosine? Yep, Gary.
1, 0, negative 1, 0.
Perfect. 1, 0, negative 1, 0, 1. Okay, you get 5 points right there if you get that. Okay, off to the side, let's put the original x's. Corbin, can you remind me, what are my original x's again? Sine and cosine are both the same.
0.
Okay, so 0, yep.
Pi over 2.
2.
Pi. 3 pi over 2. 2 pi.
2 pi. Okay, so we get the original x's. And now, be careful, what are we going to do to all those x's?
Subtract pi.
Subtract pi, yes. All right, some of these are quick because you really already have common denominators. What's 0 minus pi?
Negative pi.
Negative pi. How about pi minus pi?
0.
0. And 2 pi minus 1 pi?
Pi.
Pi. All right. Now, let's do pi over 2 minus pi over 1. What's your common denominator between 1 and 2? 2. So multiply the bottom by 2, top by 2. What's 1 pi over 2? Take away 2 pi over 2.
Negative 1 pi over 2.
Negative 1 pi over 2. And the next one, well, it's pretty much the same thing we just did, except it's 3 pi over 2. So what's, that's just pi over 2. Yep. And there's your 5 points this time. So if you put it in degrees, I think you'd see they're all equally spaced. Pretty simple. It's negative 180, negative 90, 0, 90, 180. Those are your points. Okay. Questions on the table? All right. So use those x values when you set up your labels. This time you need 2 negative labels, so start Start there with negative pi. Negative pi over 2, 0. And technically you don't have to label the y-axis because you're just going by ones. But the x-axis you do want to label. And then what I do to quickly graph it, once I put my labels, I just remember the y's. 1, 0, negative 1, 0, 1. So 1, 0, negative 1, 0, 1. Now it looks like the points kind of make a V shape. But remember, it's part of a wave. So what we're really going to be sketching is this. So try to make it look a little bit more curved than coming to like a point. Like that. That's it. So any question on that one? So that was a shift of pi units, or 180. The one before was a shift of pi over 2, or 9. You can shift any amount you want. I mean, you could shift it by 14 units, if you wanted to use the number 14. But we generally don't. We usually shift by like 90, 180, 45. It's usually a multiple of 45. It doesn't have to be. How much of a shift is this one if you did it in degrees? Yeah, this is a 45-degree shift. So this is going to be the smallest shift we've done. It's just going to move it a little bit. Okay, hopefully by now you know why it's a phase shift. Adding inside parentheses. Y values are going to stay the same. And then what are my y values for the original sine function?
Sine was 0, 1, 0, negative 0.
Okay, and Jacob, how about my original x's?
Pi over 2, pi, 3 pi over 2, and 2 pi.
Anything else?
So 0.
Yeah, first one is 0. Okay. Carlos, what are we going to do to all the x's this time?
You can shift them to or subtract pi over 4.
Right, we want them all to move to the left. The only way they're going to move to the left is if we subtract. Now, this is one where you don't have any common denominators. But I think after you find the first 2 or 3, you start to see the pattern. And then you can just kind of go from there. All right, so the first one. What's 0 minus pi over 4? Just negative pi over 4. Now the next one is pi over 2 minus pi over 4. What's your common denominator between 2 and 4? 4. 4. How can you make 2 into a 4? It has to be multiplied. Yeah. So multiply by 2 and times 2. What's 2 pi over 4 minus 1 pi over 4? Ooh, that's what we're starting with, 2 pi over 4.
Pi over 4.
And we're subtracting pi over 4, so pi over 4. Anyone think they see what the next one would be?
2 pi over 4, which would be pi over 2.
So pi over 1 minus pi over 4. What's your common denominator? 4. So multiply bottom and top by 4.
pi over 4.
3 pi over 4. Okay. How about the next one? Yeah,
5 pi over 4.
5 pi over 4. And the next one?
7 pi over 4.
7 pi over 4. Yep. So the pattern here is the number in the numerator goes up by 2. So then the next one would be 9 pi over 4, 11 pi over 4, 13 pi over 4, and so on. We stop there. Because that one's a little tricky, just to get the values. But those are the values we're going to use when we label our graph. Now, we got to be careful when we label the graph. Just for the second, just think about the numbers in front of pi. You've got negative 1, 1, 3, 5, 7. However you would space those numbers on a number line is exactly the same way you space these numbers. You just have to put a pi over 4 on each one of them. But the spacing is the same. So let's think of a number line. And let's put 0 right there. Where would negative 1 go? Right before 0. How many before 0? 1 unit. So there's negative 1. Where does 1 go? 1 unit after 0. Now where does 3 go? 3 units after 0. So notice we skipped 1. We had to, because that's 2. We don't want to put that dot there. It goes to 3. So then where does 5 go? Right next to it, or do we skip 1? Yeah, you've got to skip 1 every time now. That's just because of the way the numbers are. And then 5, and then that would be 6, and then you skip 1 to get 7. Right, so let's set up our graph, and you're going to have to do your spacing just like that. You need to skip, just because of the way the numbers are. All right, so here's negative 1 pi over 4. That's 0. That's positive 1 pi over 4. And then we're going to go to 3, 5, and I'll make one more line for 7. So this is the 3. That's the 5. Oh, no, I think I have enough. Did we have 9 pi over 4? No. So yeah, we have plenty. You'll know if you don't label it right, because when you do your graph, it might look something like this. If part of it looks squished and the other part doesn't, then that you must have labeled something wrong. Okay, it should always look nice and like even. Okay. And 0, 1, 0, negative 1, 0. 0, 1. No, see, I messed up. I did need one more. I put it on the wrong spot. I could tell when I was putting my dots that these two were too close and it was going to look squished. That wouldn't have been right. So there, skip, and then we'll just add in one more line. Okay, so 0, 1, 0, negative 1. That looks okay. It's not bad. Okay, so any question on that one, or why we had to skip? It's really because 0 was not in the table. When 0 is not in the table, then you have to skip 0. You can't put a dot on it. And then if you skip 0, you're going to have to skip all the way down. Okay, so any question on the phase shift? Out of the two transformations that we do, that's the harder one. The reason I think it's harder is because you've got to find all these common denominators. Okay, you have to work with fractions with pi. When we do a vertical shift, it's easy. All you have to do is do arithmetic with 1s, 0s, and -1s. Very easy to add and subtract from the y column. And that's going to be the last one we look at.
Go back for a second.
Yep. Yep. Okay, when we do a vertical shift, are we looking for a number that's inside the parentheses or outside?
Outside.
Yeah, outside. Are we looking for multiplication on the outside or addition or subtraction? Addition or subtraction. Yep. So what makes something a vertical shift? You add or subtract a number on the end. Notice I use the letter D. The reason why I use the letter D is because when we do all 4 transformations together, vertical shift is the last one you do. A, B, C, D. Horizontal shift, I use the letter A because it's the first one. So big difference here between a phase shift and a vertical shift. What you're adding or subtracting is outside the argument. The only way it is a phase shift is if the x and the number are in parentheses. What if I did that? Is that a phase shift or a vertical shift now? Still a vertical shift. The x and the number are not together. Okay, the only way it would be a phase shift is if I did that. That's a phase shift. It has to be inside the parentheses with the x. Okay, so it's vertical shift, so it's going to go up and down. Which way does plus normally move? Up. And minus? Down. So this is not backwards. Somehow you have to remember that. Horizontal shift is backwards. Vertical shift is not. Yep.
Parentheses supposed to be around that there.
It was just an example of how you can add parentheses and it's still a vertical shift.
Alright.
Even if you did this, still a vertical shift. Just adding parentheses does not make something a phase shift. It has to be parentheses in a certain way. But no, I normally would not put parentheses. I would write it like this. Just extra parentheses. Okay, so add moves up, subtract moves down. Don't do the opposite. Out of the 4 transformations we studied, 2 of them you do the opposite, 2 of them you don't. Okay. Horizontal is always the opposite. Vertical is never the opposite. All right, so we know what we're looking for. Okay, something that looks like this. It's a vertical shift. We know which way it would move it, plus we move it up. Now, what value is going to be affected? The y's. Yep. So this time, the x's stay the same. So for every vertical shift you do in tonight's homework, the x's are 0, pi over 2, pi, 3 pi over 2, 2 pi. Every vertical shift. So if the x's are staying the same, it's the y's that are going to change. And all we have to do is add or subtract whatever number is on the end to the original y's. Don't do the opposite. Right? If your problem has a +2 on the end, do a +2 to all the y's. If your problem has a -5, do a -5. Don't do the opposite. And remember where D comes from. D is the number that's at the end. So in that case, it's a +3. So we'll try 2 examples of that. We'll do 1 shift up, 1 shift down, and that'll be it. Okay, so first question, how do you know whether that problem is a vertical shift or a phase shift? I know it's a shift because I see adding or subtracting.
X and 2.
Right, the x and the 2 are not grouped together in parentheses, makes it a vertical shift. Okay, when we do a vertical shift, which column in the original table is not affected? Yep, the x's. So let's write them down. 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, my final answers are going to go in there. But off to the side, just like I did before, I'm going to put the originals. Okay, what are my original y values for the cosine function?
-1, 0, -1, 0.
Okay. 1, 0, -1, 0, 1. And now we need to adjust. What do we do to all of them?
Add 2.
Add 2. Very easy arithmetic. Okay. What do you get for your new y values if you add 2 to all the old ones? 3, 2, 1, 2, 3. Yep, that's it. And that's the arithmetic for a vertical shift. Questions on how we got 3, 2, 1, 2, 3? Okay, so now I'll label my graph. I'm going to go 0, 1, 2, 3. And I do have graph paper in the back. Most of the time I just sketch my own. But if you want to borrow, you can just take some on your way out. Right, and x is labeled the same way that you have in the table. 0, pi over 2, pi, 3 pi over 2, 2 pi. All right, so we got 0, 3. 2, 1, 2, back to 3. So this is the cosine one. It's the middle part of the wave. Looks kind of like the V, but remember it has a curve. That's okay. All right, so that's the new one, and it's been shifted up to. Any question on that one? All right, let's try the last one. So sine of x minus 3. David, what makes this one a vertical shift versus horizontal? David, right?
Yeah.
Okay, I'm just making sure. What makes this a vertical shift and not a horizontal?
Plus. Well, yeah, the plus. My fault. The -3 at the end.
Yes, the -3 is at the end, right? It's not in parentheses with the x. Okay, so that makes it a vertical shift. How about Ethan? What values are going to stay the same when we make our table? Yeah,
B, right? Not the other one?
not the other one.
Okay. I'm going to be keeping the x values.
We're going to keep the x values. All right.
Would you like me to list them?
Sure.
0, pi over 2, and this one, pi, 3 pi over 2, and then 2 pi.
Okay, so we got our original x's. And how about Ethan, the other one? What's the original y values for sine?
Sine 0, 1, 0, 0.
0. And Sean, what am I doing to all those y values?
You're adding 3 and subtracting 3 from them.
Subtracting 3. Yep. And Logan, if I subtract 3 from all of those, can you give me my new y values?
-3, -2, -3, -4, -3.
Perfect. Any questions on the table? All right, so as I've said before, you get 1 point for each x and y, so that's 10 points. And then the sketch, that'll be a couple points. Okay, this time I'm going to put my x value labels above because I know the graph is going to be shifted down. So when I draw, I try not to draw over my labels. Okay, just looks easier to read. So put your labels up here. And you definitely will not be drawing over them because they're going to be your graph is shifted down. Do we go below -4? No. Good enough. Okay. So we got 0, -3, -2, -3, -4, and back to -3. All the points look nicely spaced. And there's your sine function shifted down 3. And remember, how far left and right does that wave go? Infinite, right. So, I mean, it just keeps going. But we're only sketching one site. Okay, so those are the shifts. Tomorrow, we will look at the stretches. Stretching left and right, stretching up and down. Okay, any questions on it? Okay, so that's 6.3 part 1. So the homework is those 7 graphs. So you can check on Schoology. I know they are on there. I'm not sure if I did graph paper online. I might have. So you can check there, and you can print it. You'll have graph paper. Or if you really want it, just grab it under the TV in the back. In the pile, there's different kinds, so you can look through and see which ones you like.